Alright, we have another new question here. A race car accelerates uniformly from a speed of 20 meters per second to a speed of 80 meters per second in 6 seconds. Now, the race car started from 20 towards to 80. That means initial to final velocity. I told you that speed is same as velocity because they are both measured in meters per second. And it takes time for it to move from 20 to 80, which is what 6 seconds. That was the time it took to move from 20 to what? To 80. Now we're told that when traveling counterclockwise around a circular track of radius 2 times 10 raised to power 20 meters, we were given our radius. When the car finally reaches a speed of 60 meters, which is the total velocity, then we're asked to find the magnitude of the car's centripetal acceleration and the angular what speed, the tangential acceleration, and the magnitude of the total what acceleration. All right, now from here we're given our u to be 20 meters per second, and we're giving our v to be 80 meters per second, and we were given our time, which it took to move from 20 to 80, to be 60 seconds, and we're given our radius to be 2 times 10 raised to power 2 meters, that is 18 as well 200 meters. Then we're given our total velocity, which is the final velocity, to be what 60 meters per what seconds. Now number one, we are asked to look for the what the centripetal what acceleration, that's AC, and number two, we are asked to look for the angular what speed, which is omega. Then number three, we are told to look for the what the tangential acceleration, which is 80. And finally, the last one, we're asked to look for the what the total acceleration. Either I call it total acceleration, you call it resultant acceleration, or you call it radiant acceleration. They are all mean the same thing, which is our what a arrow. All right, now this time around, to get our AC is sitting at v squared over r. Okay, take note, this velocity you have to use is of final, which is the total overall velocity. Now it becomes 60 squared, then all over 200. Now 60 squared is going to give us 360. Sorry, 3600 divided by 200. So it's going to give us 18 meters per second square. That's number one. And number two, we're asked to look for the what? The angular speed, which is omega. I gave you W equals to what? V over R. This formula was gotten from V equals to WR. Making W the subject of the formula, you divide both sides by R. This cancel out this, your W will give us V over what? R. Alright, so from here, our V is 60 divided by 200. So 60 divided by 200, so it's going to give us 0.3. So rad per seconds. All right, so the next one, number 3. So we're asked to look for what? The tangential what acceleration, 80. I gave you different formula for tangential acceleration. I gave you 80 equals to alpha arrow. I also gave you 80 equals to v over t. I also gave you 80 equals to v minus u over t. The main reason why we can't use this because we are given our initial and our final word velocity, and we can't make use of this because we don't have our alpha. Okay, now this time around, the only formula that can work out from there is this. So from there, our 80 is equals to v minus u over t. And this time around, we have to make use of which velocity, which is 20 and what? 80. So we give us what? 80 minus 20, then all over 6. And 80 minus 20 is going to give us 60 over 6. And 60 divided by 6 is going to give us 10 meters per second square. All right. Now, the last question there, we are asked to look for the what? The total acceleration, which is number 4. To get the total acceleration, is sitting as AR. AR is equal to square root of AC squared then plus AT squared. Alright, so from there it becomes our AC is the same thing as 18 squared, then plus, and our AT is same thing as 10 squared. So our AR becomes square root of 18 squared is going to give us 324. Then plus 10 squared is going to give us 100. So we give us square root of 324 plus 100 is going to give us 424. And AR square root of 424. So it's going to give us 20.59 meter per second square. So as easy as possible. All right, so let's move down to the next question.